Hello students, we are solving the IB Math A HL past papers and currently we are solving the IB Math A HL May 2021 paper 2 time zone 1 and we are solving one question each day. Today we will be solving question number 6 of this paper and you will be getting the links to all the previously solved questions in the description area in the playlist. So without any further delay, let us start with our today's session. Question number 6. It contains 5 marks and it says consider the planes pi 1 and pi 2 with the following equations. Pi 1 is 3x plus 2y plus z equal to 6 and pi 2 is x minus 2y plus z equal to 4. Okay, and subpart A says find a Cartesian equation of the plane pi 3 which is perpendicular to both pi 1 and pi 2 and passes through the origin 0, 0, 0. Okay, and it contains 3 marks. Fine. So from pi 1, we know what is the normal to this plane, the first plane. The normal vector to that plane, to the first plane, is equal to 3, 2, and 1. Okay. And the normal vector to the plane 2 is equal to, we are just taking the coefficients, 3, 2, and 1. Okay. And the coefficient of the normal vector to the plane 2 will be 1x, so it is 1, minus 2y, so it is minus 2, and 1z, so it is 1. Since it is a 3D question, you may get confused. So this one will be very easy to sketch actually. These two are two planes, not necessarily, they are not, they have not said that the planes are parallel. They are in fact not parallel because their perpendicular vectors are not parallel. So the planes are not parallel. So I can draw the two planes of this type. Just imagine a plain simple room. A simple room consists of 4 walls, the floor and the ceiling. Okay, just imagine a simple room. So how do I draw let me draw the walls and the ceiling, the floor. I can draw the ceiling as well, but drawing the floor will be easier for me. So this is one of the walls. This may be the second wall. I'm not at all good in drawing, so please excuse. And this will be the floor. This will be the floor. Okay. So this may be pi 1, the plane 1. This is plane 2. And these two are the two normal vectors to the two planes. So I can draw the normal vector over here as well. I can draw this as n1. But in order to make it relatively simpler to understand, I can draw the normal vector to any plane anywhere in the plane. So this plane is touching this floor, so I can draw the normal vector over here as well. This is the normal vector n1. Okay. And this will be the normal vector for the plane, second plane. This is the normal vector having this direction, and this normal vector is having this direction. And they are saying that the third plane is perpendicular. We are seeing, obviously, we know that the floor or the ceiling, they are perpendicular to the walls. I'm considering a simple room. Don't try to think about arched rooms and all. Simple room with rectangular walls, the ceiling and the floor. Okay. So now, if I have to get the equation of the third plane, that is the equation of the floor in our case. So we have been given the coordinates of the point through, that is the origin through which the third plane passes. Because the first two planes are also passing through this point. So, but they are not saying that 0, 0, 0 is the common point between these three planes. They are not saying that. 0, 0, 0 may be this point as well. Okay. Don't take this point to be 0, 0, 0, but maybe it may not be. Okay. So you can have, but 0, 0, 0 is a point through which the third plane passes. Fine. So since we are given the coordinates of a point which lies on the plane, let us find the normal vector, the vector which is normal to this third plane. Okay. So this can be the normal vector. It is moving up. It can move down also. So I'm taking this as n3. It is the normal to the third plane. How do we get that? How do we get the vector? If we do the vector product of n1 and n2, the vector that we will be getting, the vector product of two vectors, is another vector, and that vector will be perpendicular to the two vectors whose vector products we have taken. So n1 and n2, if we take the vector product of n1 and n2, the vector product that we will be getting will be perpendicular to the plane containing n1 and n2, and we are seeing that n1 and n2 are on the plane, on the third plane. That is why I have drawn the n1 and n2 vectors on the third plane, so that it simplifies the situation. Okay. So n3 is a vector which is perpendicular to both the n1 and n2 and is perpendicular to the third plane. Let us find n3. So n3 will be equal to n1 cross n2. And we need to do the vector product. You can use your formula booklet. I'm doing it over here. So this will be ijk first of all, I'm taking n1 3 2 1 and into 1 minus 2 1. 1 minus 2 1. Let us check once more. 1 minus 2 1 and 3 2 1. So the vector product will be, when we take the I, we will be excluding this I column, and we will be taking these 4 numbers. Okay. So it will be 2 times 1 2 times 1 minus 2 times 1 minus 2 times 1. Okay. Always we go from the top left to bottom right, and then we come back. See, this is a minus sign formed. So it is a minus sign in between. And then we move from bottom left to top right. This is the process. This is the way that we calculate the vector product. And then you have to remember that J will be having a minus sign in front. This is important. And this will be, for J, we will be excluding the middle column, and we will be taking 3, 1, 1, 1. So 3 times 1 minus, we come back, it is 1 times 1. Plus, you have to remember this middle one is negative. Plus, now it will be the K. We will be excluding the K column and we will be taking 3, 2, 1, minus 2. So it is 3 times minus 2 minus 1 times 2. Okay. This is, therefore, N3 is equal to 2, and this is minus 2 times 1 is minus 2. Minus of minus 2 is plus 2. So 2 plus 2 is 4. 4i. This is 3 times 1 is 3, and this is 1. 3 minus 1 is 2. Minus 2j. 3 times minus 2 is minus 6, and this is minus 2. So minus 6 minus 2 is minus 8. Minus 8k. Okay? You can write it in this form as well if you want, 4 minus 2 and minus 8. I have written in unit vector form. So we have got the normal vector which is normal to the third plane, this one. Okay? This is by 3. And now we have got the one of the points, that is the the origin, 0, 0, 0. So what is the normal equation for a plane? It is r dot n. You will be getting these in your formula booklet. If you don't remember, then you can consult the formula booklet. R dot n will be equal to n dot a or a dot n. Scalar product, these are scalar products. So scalar product is commutative. R dot n is equal to n dot r. Same for n dot a. You can write a dot n as well. So r, what is the r? R is the position vector of any point on the plane having the coordinates x, y, z. And n is the normal vector to that plane that we have found, this one. And a is the position vector of a point whose coordinates are known and which is on the plane. In this case, the coordinates are 0, 0, 0. Okay. So the position vector of this an arbitrary point on the plane having coordinates x, y, z will be x, y, and z dot I can write xi plus yj plus zk. That also I can write, because I have taken the normal vector in unit vector form. I should have written xi plus yj plus zk. But since I have taken this in component form, let me take this also in component form. So 4 minus 2 minus 8 equal to, again, 4 minus 2 minus 8 dot, the position vector of this point A will be 0, 0, 0. Okay. So we have to do the dot product. Therefore, it will be 4x minus 2y minus 8z is equal to 4 times 0 is 0 plus negative 2 times 0 is 0 plus negative 8 times 0 is 0. So this is the equation. Okay. To find the Cartesian equation of the plane pi 3, we have given the Cartesian equation. Okay, and this was in fact subpart A. I did not mention that. This was subpart A. And now subpart B. Find the coordinates of the point where pi 1, pi 2 and pi 3 intersect. Okay. So we have the three equations of the three planes. Let me copy the first two equations. First one is 3x plus 2y plus z equal to 6. Subpart B. Oh, over here I'm seeing 4x minus 2y minus 8z equal to 0. You can divide this entire equation by 2 as well. So you can keep the answer in this form. No harm. No mark will get deducted, or else you may write this as x minus y minus 4z equal to 0. You may write this as well. Okay. But even if you write this, you don't lose any mark. Let me again see what was the equation for the first plane. 3x plus 2y plus z equal to 6. 3x plus 2y plus z equal to 6. And equation of the second plane, it is x minus 2y plus z equal to 4. X minus 2y plus z equal to 4. Let me check once more. X minus 2y plus z equal to 4. Right. And we are having the third equation. Let me just, because I had written this first of all, so let me just take this. And okay, I'll be taking these two, and I'll be showing you. The question is asking for giving us the intersection point, or the coordinates of the intersection point. So let us see if we get, whether we get different coordinates for when we take this one and when we take this one. First of all, let us take 4x minus 2y minus 8 equal to 0. 4x minus 2y minus 8z equal to 0. I sometimes I write z in this form, sometimes I write z in this form. So Don't get confused, okay? And this plus 2i minus 2i, this also plus 2i minus 2i. So it will be a very easy thing to solve, but do we need to solve because it is paper 2? How many marks does this contain? Okay, only 2 marks. It contains only 2 marks. So let us use the calculator. We need menu and then algebra and then solve system of linear equations. Number of equations is 3. And variables, yes. Okay. And now I have to type in the equations. The first one is 3x plus 2y plus z equal to 6. 3x plus 2y plus z equal to 6. 3x plus 2y plus z equal to 6. X minus 2y plus z equal to 4. X minus 2y plus z, right? Plus z equal to 4. Plus z equal to 4. And this one is 4x minus 2y minus 8z. 4x minus 2y minus 8z minus 8z equal to 0. Fine. Hope I have entered everything correctly. And enter. 41 over 21, negative 10 over 21, 23 over 21. So let me just write the values. Using GDC, x equal to 41 over 21, right? 41 over 21. Y is equal to negative 10 over 21. And z is equal to 23 over 21. Okay. These are the actual values, exact values in fraction, but if you need in decimals, I can get them in decimals. Let me try. Control enter. Yes. Thank you. Okay. X equal to 1.95 up to 3 significant figures. So these were exact values, but now these are approximations because I'm taking only up to 3 significant figures. 1.95, 1.95, y equal to negative 0.476. Negative 0.476. Z is equal to 1.095. So it will be 1.10. Okay. 1.10. So the coordinates of the point will be 1.95, comma, negative 0.476, comma, 1.10. Coordinates of the point of intersection. Okay, fine. Now let us use 2x minus y minus 4c in place of this. Okay, let us check what values do we get. So again, we will be going to menu and then algebra and solve system of linear equations. It will be 3 and then it will be this and fine. Again, the first two remains the same. So I can just copy 3 times x plus 2 times y plus z equal to 6. Second one is x minus 2y, 2 times y plus z equal to 4. And the third one, I'll be just straight away I'll be dividing this by 2. So it will be 2 times x minus y minus 4 times z equal to 0. And control enter. You see, I'm getting exactly the same values for the coordinates of the intersecting point. Okay, so it doesn't matter whether you take the equation of the third plane to be equal to 4x minus 2y minus 8z equal to 0 or 2x minus y minus 4z equal to 0. Okay, you get the same intersection point. And in fact, these two are the same equation. If you divide by the first equation by 2, you get the second equation. Okay. So, most probably we have completed solving the question number 6 completely. Yes. Yes, we have. And so, thank you for staying with me till the end. And we meet again tomorrow. We'll be solving question number 7 of this paper tomorrow. And if you have any question, any doubt, please do write to me in the comment area. If you have any suggestion, you may mention those as well. I'll be trying to modify or I'll be trying to answer your doubts as much as possible. And you are seeing my email ID, you are seeing my WhatsApp number. They are getting displayed. I'm starting group online math tutoring sessions from July for IB Math A, SL and HL students. If you are interested in joining my classes, please do write to me. You may write to me, you may text me, you may mail me. So, till tomorrow. Bye.